We've all been there, right? You run a standard video cable, maybe 15, 20 meters, and suddenly you're fighting a losing battle.
Oh, yeah.
You get digital snow, flickering, the works. But what happens when you need to send a signal, not just across a big room, but across an entire kilometer?
Yeah. What then?
Well, today we're doing a deep dive into a piece of gear designed for exactly that problem. It's the Avenview FO-DVI-1000M-EMI extender system.
It's a very specialized piece of kit, and its whole mission is, pretty straightforward.
Yeah.
It's built to solve the two biggest headaches in Pro AV:
Which are?
extreme distance and signal interference.
Okay, let's jump right into the specs then, because the headline claim is it's wild. 1,000 meters, that's 3,300 feet.
It's a huge number.
But I was looking at the data sheet, and I noticed there's a bit of a catch. You don't get that full distance for free, do you?
No, you definitely don't. Physics always gets a vote. With a system like this, the trade-off, the currency, is resolution.
Yeah.
It's a sliding scale.
Right, I saw that. So if you want to run at WUXGA, that's 1920 by 1200, a pretty standard high-res monitor, you only get 500 meters.
Which is still incredibly impressive, let's be clear.
Oh, absolutely. But it's only half the advertised max distance.
Exactly. To actually hit that 1,000-meter number that's on the box, you have to drop your resolution way down to SXGA.
And SXGA is, what, 1280 by 1024? That's old school square monitor territory, isn't it?
It is. It's a throwback, for sure. But think about the use case. For industrial control rooms or, simple digital signage, raw pixel density isn't the priority.
Readability and range are what matter.
Exactly. The takeaway is simple. Distance costs you pixels.
Mm-hmm.
So you have to decide what's more important for your specific installation.
That makes sense. Now let's talk about how it does this. It's not using some massive bundle of copper wires. It's a single strand of SC multi-mode 1 fiber. That feels like a lot to squeeze down one tiny pipe.
It sounds like it should be a bottleneck, right?
Yeah.
But fiber has massive bandwidth. The real challenge isn't the space, it's the timing.
What do you mean by timing?
Well, a DVI signal has your red, green, and blue channels, of course. But it also has the clock signal.
The clock signal.
Think of it like a metronome for the data. It keeps every single pixel perfectly aligned. If that clock drifts by even a nanosecond over the philometer,
The image just tears itself apart.
it's gone. The real engineering magic here is packing all those colors, plus that critical metronome beat onto one beam of light, making sure it doesn't lose sync.
And usually a cable run that long isn't going through a quiet, carpeted office. It's probably in a factory, maybe a hospital.
Which brings us to the other part of the name, the EMI, electromagnetic interference.
Right. Those environments are just deafening, electrically speaking.
They're a nightmare. You have huge motors, high voltage lines, a long copper cable in a factory basically turns into a giant antenna.
Just sucking up all that noise.
All of it. And it completely destroys your picture. But because this Avenview system uses light, not electricity, it's totally immune. You could literally zip tie the fiber to a high voltage power line and the video wouldn't even flicker.
That reliability has to be the key selling point. I was also surprised by the hardware itself. The actual transmitter and receiver boxes are tiny.
Yeah, they're about 2.4 by 1.5 inches, super small.
So you can just tuck them away.
You can tuck them behind a monitor, inside a crowded rack, anywhere. But even with that small size, they didn't skimp on the logic. It handles EDI automatically.
That's the handshake data, isn't it? Where the monitor tells the computer what it is.
Exactly right. Without that, you plug everything in, you just get a black screen because the PC doesn't know what resolution to send. This system makes sure that conversation just happens seamlessly, even with 10 football fields of distance between them.
Okay, but we do have to talk about the price. I saw this listed for about $1,332. That's steep.
It's definitely a shock if you're used to buying, consumer HDMI cables online. But you're not just paying for the hardware. You're paying for the industrial hardening and the warranty.
It's a 3-year warranty, I saw.
Right. And think about it this way. If a critical security feed in a casino or a display in a hospital operating room goes down because of interference, the cost of that outage just dwarfs the $1,000 you spent on the extender.
So it's less of a component and more like insurance.
That's the perfect way to look at it. It's insurance in a box.
It really is fascinating. It puts our consumer tech in perspective. We have this industrial gear that can shoot a complex video signal a full kilometer over a single strand of glass, no problem. And it leaves me wondering, if we can do that so reliably in a noisy factory, why are we still struggling with 5-meter copper cables that flicker in our own living rooms?
That right there is the million-dollar question.
Thanks for listening to this deep dive. Go explore.